I think making sure to have some sort of performance versus expected is an absolute must. And most monitoring platforms that you'll encounter today already have some version of EPI or performance versus expected. So I'm not too worried about that. The questions that I might ask to follow on would be, first, how do you calculate it? And then digital twin would be the answer that I would hope for on that. And the target, I think, should be having a 1% to 2% margin of error if you've got on-site sensors with that full digital twin. I might then ask, what are the inputs to your digital twin? And the answer that I might look for there is, the electrical layouts, having some source of real-time irradiance and temperature, and then having that third-party performance data to underlie it. And then the third question that I might ask is, what are the outputs from that? Because again, great to be able to get expected power at a site level, but I think you should be able to also get expected voltage and current, being able to get it on a per inverter and per string basis, which just really enables you to be able to diagnose issues remotely, to be able to kind of pinpoint which pieces of hardware are the issue, and then not only avoid diagnostic truck rolls, but then when you actually do have to roll a truck, you're showing up with the right people, the right tools, and you know exactly where to go on site. So you're not looking around for an hour trying to figure out, which piece of hardware is the problem. Like I said before, like monitoring should be able to super easily pay for itself, but I think that can only happen if it delivers good insights and it's able to show you what might be happening on your site remotely.